So here on this one, we're going to do D4. Actually, it's real world situations. So we're going to do quadratics in real world. And here's our friend Yoda. He says, using quadratics, finding zeros, will you? Usually means you're finding the x-intercepts, or zeros they're called. Okay, so we're going to move on. Don't worry about that correction there. We're going to move right on over here. Okay, and we're going to go right to this question. So the first question, the quadratic relation h equals negative 5t squared plus 80 models the path of a ball that was dropped from a certain height. The h is the height of the ball in meters and t is the time in seconds. Fill in this table. So I put t, I put that, and I put h. So for this particular one, we're just going to fill in the numbers and use our calculator. So let's go in here and fill in the numbers here. So we get negative 5 times 0 squared plus 80. Okay, here you get negative 5 times 1 squared plus 80. Here you get negative 5 times 2 squared plus 80. You get negative 5 times 3 squared plus 80. I'm just filling in the numbers here. And negative 5 times 4 squared plus 80. Okay, now we're going to use a calculator to figure these out. So let's see, negative 5. So here, negative 5. We'll clear this. Negative 5 times 0 squared, not 1, 0 there, plus 80. Oh, the first one we're at 80. Next, let's go to the calculator there. Oh, I'll use that same calculator. So you get negative 5 times 1 squared plus 80. Not 81, but 80. 75. So we're down to 75. Then you get negative 5. Let's do the next one. Negative 5 times, so that's 2 squared in a bracket, 2 squared plus 80. 60. We're getting lower each time. Okay, next one, negative 5 times 3 squared plus 80. So negative 5 times 3 squared plus 80. 35. And then you get negative 5 times 4 squared times 80. So you get negative 5, not minus, it's times 4 squared, plus 80. 0. Oh, hits the ground then. So after 4 seconds, it hits the ground. Now let's graph this. So file on the table, let's graph it. So you got at 0, we're at 80. So at 0, we're going to put a dot at 80. Okay, at 1, I believe we're at 75. So 60, 65, 70, 75 are right there. Let's see if I can do that red mark here, right here. Okay, so that's there. At 2, we're at 60. So 2, we're at 60. So at 2, we were at 60. Let's see the next one. At 3, we're at 35, and at 4, we're at 0. So at 3, we're at 5. They go by 5s. 5, 10, 15, 20, 25, 30, 35. We put a dot. And then at the end, we're at 0. This is actually a parabola. I'm going to try to draw my best parabola through all this. It's actually a curve. It's not a line, so you don't have to use a ruler. And the ball falls, and it hits there at the 0. Okay, let's see what else we have to do. Graph. Label the axis and titles. Okay, let's take a look. The quadratic models the path of a ball. So here at the top, path of ball. Path of ball. Okay, over here I believe is the height in meters. And here's the time in seconds. Now, I was very nice. I gave you the graph so you don't have to actually, you can print the 2-page worksheet and the graphs are ready for you. And hopefully all the graphs will fit on the ones I gave. Okay, let's take a look at the next question. From what height is the ball dropped? Well, the ball's dropped here, 80 meters, right at the top. So 80 meters it's dropped. When will the ball hit the ground? So here's the path of the ball. Hits the ground at 4 seconds. 4 seconds. Okay, next question. So there's only 4 questions. I'll do 2. I'll do one page and you do the other page. It'll be nice and simple. Okay, let's do this one here. So we're going to put in X. We're going to put in 0, 10, 20, 30. I even tell you what to put in. Makes it even easier. So you go negative 0.02, okay, times 0, and then 0 minus 50. It's going to be a tight squeeze here. We'll move this out. Make sure there's lots of room for me to write. Next one is negative 0.02 times 10 minus 50. Next one's negative 0.02 times 20, and then you get 20 minus 50. And negative 0.02 times 30, and you get 30 minus 50. Let's continue on to the next one here. So we'll just bring this down a little bit here. So here, negative 0.02, 40, and wherever we see X, we put 40. Okay, minus 50, and we got one more, negative 0.02, 50, and wherever we see it, 50 minus 50. And now we go to our calculator. So all calculator work here. So let's go right to this calculating machine here, or the calculator, turn it on, and we'll clear this. So negative 0.02 bracket 0. Well, no cos. I don't know where that came from. Let's clear that again. Negative 0. Not having much luck. 0.02 bracket for me 0, and then close the bracket, and then 0 minus 50. And you get 0 for the first one. So 0. Next one. So on the next one you get negative 0.02 times 10, or bracket 10 times 0 minus 10 minus 50. In a bracket we'll go 10 minus 50. Some calculators you can go back and retype it, so that one's 8. Next one here. So whoops, I'm in the wrong place. So let's go to the calculator here. 0, negative 0.02. This time we use a bracket, 20, and a bracket, 20 minus 50. You get 12. So over here you get 12. On the next one, keep clicking the wrong thing. That's okay. That's my recorder or my screencaster that records this. So we'll get negative 0.02 times 30. This time I'm going to put 30 in a bracket, times 30 minus 50. Not 31, but 30 minus 50. 30 minus 50, close the bracket. And you get 12 again. I wonder if the next one's going to be 8 and there's a pattern. Let's take a look here. So you get negative 0.02 bracket 40, bracket 40. Oh, forgot to close the bracket, bracket 40 minus 50. Again, 40 minus 50. Eight. And I've got a funny feeling the last one's going to be 0, but we'll type it in the calculator to figure out what it is. So negative 0.02. Okay, times 50 times bracket 50 minus 50, which is 0. Not 51, 50 minus 50. Close bracket, 0. Okay, let's graph this person. 0, 8, 12, 12, 8, 0. See if I remember that. 0, 0. So we start here. So let's go a little lower. 0, 0. We'll put a dot here. So let's use my pen here. A red dot. 0, 0. Here. Next one, 10, 8. So 10 all the way up to 8, put a dot. Next one, 20, 12. 20 up to 12. And the next one's, I think, 30, 12. Then we match over here, 48. And is it 50, 0? Let's see, 50, 0. So here we go, 50, 0. So it comes up, curls around here, I think, and then comes back down. Perfect. Okay, let's take a look what it says here. A bridge can be modeled. So this is a bridge. X is the distance, and X is the distance across, and Y is the height. So we'll say bridge up here. We'll use the word bridge. Here's distance. No, this is height in meters. And down here is distance. So we're going to label it distance in meters. Let's see, any other questions, or is that it? What is a point on the bridge? Oh, that doesn't make sense. How wide is the span? Okay, what is the highest point? I think it says highest. So I think that's supposed to say highest point, not the point. Well, according to the graph here, I think it's higher, but according to this graph, we definitely know it's at least 12, but it might go a little higher. It might go to 13. So I'd say 12 meters, possibly 13. Okay, if the vertex was higher, possibly 13 meters. We'll go with the 12 meters. That's the highest number. How wide is the bridge? So the bridge goes from here to 50, so it's 50 meters wide. So 50 meters wide. Okay, now the questions you have to do. So let's see if I have them open here. So again, so this should be what is the point? I mean, this should be what is the highest point. Now you got to do another bridge one that's very similar to this one, except it's at negative 0.1, and hopefully you can fit it on this graph here. And then you're going to do this one here with a glacier comes down. So you're going to get a parabola down here. It shows you the picture, and you go from 0 to here. How wide is the glacier, and what's the deepest point? You should be able to figure it out when you enter it. So you got two more questions to do. This one's similar to the first one, and this is similar to the other one.